はい、皆さん、こんにちは。私はウベル・ルスと申します。今、51歳です。フランスのトゥロン大学を1996年に卒業しました。京都大学の深尾先生と山本先生との出会いは、1995年、アメリカで開かれた MST ワークショップでした。立種の合併の前、ラスクに1998年から2002年までポストドクとして在籍し、その間、エミュレーダーを使ってさまざまなプロジェクトに取り組みました。この経験のおかげで、2000年からフランスに帰って、トゥロン大学で准教授の地位を終えることができました。でも、その後も、エミュレーダーやイクワトリアルアトモスフェアレーダーを使った研究で、深尾先生と山本先生と橋口先生の研究室と、共同研究を行い、立種と、密接な関係を続けてきました。実は、立種には何度もビジティングサイエンティストとしてお招きいただきました。そして、立種の皆さんのおかげで、今年の春から、京都大学国際高等教育院で、教職活動及び研究活動立種で、ができるようになり、再び、日本に住むことになりました。私の趣味は、自然に触れるガーデニングとかハイキングとか秋のキノコ採取です。日本では、温泉と、銭湯に行くのが大好きです。私の専門分野は、大気圏観測データ解析です。研究活動の説明するのが、難しいですから、日本語で。だから今から、英語で説明したいです。So my research is focused on small-scale atmospheric dynamics, mainly turbulence and waves, using ground-based remote sensing and in situ techniques. Also, I'm also interested in the larger-scale phenomena, which promote or generate these small-scale processes. Atmospheric turbulence can play an important role through vertical mixing in the irreversible transport of heat, momentum, and materials. So the quantification of turbulence is very important in order to model correctly the atmospheric circulations at various scales and the transport of anthropogenic pollutants in the atmosphere, for example. My work is upstream, and I work on the characterization of turbulence from the boundary layer near the surface up to the lower stratosphere in both convective and stratified conditions. A large part of my activities consisted in interpreting the signature of these small-scale processes in the observation data. So the data are interpreted in the light of complementary measurements, models, and theories to understand their nature, to understand the generation mechanisms of these small-scale processes, and finally to quantify parameters, for example, turbulence parameters. I think that one of the most prominent results I obtained with the MU radar, in association with MI-Relay LiDAR for cloud observations, was the first evidence of turbulence produced by convective instability at a cloud base in an upper level frontal zone. This convective instability was produced by cooling due to evaporation or sublimation of precipitation within a dry and weakly stratified subcloud layer. This mechanism has been predicted, confirmed, and quantified by numerical simulations produced by JMA, Japan Meteorological Agency, and these numerical simulations are operationally used to predict such kind of phenomenon because it can be sometimes a source of quite severe turbulence. So since 2015, owing to collaborations between RICH and Colorado University members, namely Professor Kanter and Professor Lawrence, my activities has expanded to the analysis of turbulence data collected from unmanned aerial vehicles, UAV, with temperature and turbulence sensors. This technique is quite recent, and I think it's a small revolution in in situ measurements techniques because of their flexibility in use, their low cost, and many advantages with respect to standard radio soundings by balloon, for example. So I think that in combination with remote sensing technique, the UAV technique can provide new insights in atmospheric dynamics and in atmospheric turbulence in particular. So finally, I would like to conclude by saying that my recruitment at RICH constitutes a unique opportunity for me to carry on and to expand my research activities with new and existing collaborations in Japan and abroad. So my wish is to contribute at my small level to the influence of the Institute by conducting new projects, not only at Shigaraki MU Observatory, but also at other locations. And of course, I will focus on the preparation of original lectures or courses for the students of the Institute of Liberal and Art Sciences, ILAS of Kyoto University. And finally, I would like to say a few words in French. Je voudrais remercier toutes celles et tous ceux qui ont participé directement ou indirectement à mon recrutement à l'Université de Kyoto et au RICH. Et je voudrais finir en ayant une petite pensée pour toutes les personnes de mon entourage que j'ai laissées derrière moi en m'installant au Japon. Arigatou gozaimasu.